Hey everyone, welcome to Data Engineers Launch number 76. We'll go ahead and give everyone a couple more minutes to file in and we'll get started shortly. Hey everyone, welcome to Data Engineers 76. We'll go ahead and give everyone a couple more minutes to file in and we'll get started shortly. But while you're here, don't forget to hit the subscribe, turn on that notification because we go live and every time we post a video or a video. How's this now operating? Alrighty, hey everyone, let's go ahead and cut the music. Thank you everyone for joining us here for Data Engineers launch number 76. Today's talk is going to be on Airflow and Google Dataproc. I will be the speaker for today. I'm an engineer here at Anant. If you weren't here for Cassandra launch on Thursday, that's where we did this demo that we're going to be doing today manually. But today we'll show you how it takes, or what it takes to essentially do what we did manually in the Google Cloud UI and do it in Airflow via DAG. Co-organizers for this event are Rahul and myself. If you are interested in giving a talk here at Data Engineers Launch or Cassandra Launch, feel free to reach out to me. My email is listed below, as well as if you're interested in sponsoring Data Engineers Launch or Cassandra Launch, feel free to reach out to me as well. Here, we are a part of Data Community DC. Data Community DC believes in building an inclusive environment, so no matter your race, gender, or social orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built of a bunch of different organizations. We fall under Data Wranglers DC, so if you're interested in all the various events, check out datacommunitydc.org. So what do we cover here at Data Engineers Launch? We cover everything that from the ingress to egress of data, everything that happens in data cleansing, wrangling, ETL, and all the tools and technologies surrounding it, including databases to low-code, no-code ETL tools, and the sort. If you're new here, say hi, hello in the YouTube chat. Group rules, if you have a question, feel free to ask it in the YouTube chat. I have the YouTube open, so I'll be able to read the chat as we go along. And if you have any experience or any insight into what we're talking about today or in the future, feel free to drop that in the YouTube chat as well. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us here. GW University helps provide venue space when we have in-person events. We have some organizational and institutional sponsors. If anyone is looking for a job or has any jobs to offer, feel free to drop links to those in the YouTube chat, as well as any meetups, hackathons, conferences, or classes they would like to promote. Feel free to drop those in the chat as well. Anant is hiring full-time or part-time positions, data platform operators, engineers, or architects. You can find out more at careers.anant.us. Upcoming events, Data Engineers lunches happen weekly on Mondays, and Cassandra lunches happen weeklies on Thursdays, both at noon Eastern currently. Keep an eye out. We do have holidays upcoming, I believe. Next Monday or the Monday after, we have a holiday, so we'll keep you guys updated. You can check out our live schedule. We've also released our 9th free Apache Cassandra runbook. This one covers getting started with Cassandra troubleshooting, some tips and know-hows, some things that you can use quickly, as well as starting and restarting your Cassandra service if it ever goes down. You see down normals in your node tool status. How do you resolve that? And so we'll drop the link in the YouTube chat so you can get it there as well. And with that, we'll go ahead and move over to today's topic. Okay, so again, as mentioned, today we're going to cover Airflow and Google Dataproc. The demo code that we're going to use, which is now public, let me drop the GitHub repo in the YouTube chat. Okay, and so coming back here, what we're going to be doing is essentially what we did on last Thursday, which is where we created a cluster on Google Compute Engine, Dataproc cluster on Google Compute Engine. Then we submitted a job to it manually that did a select all from our Astra database key space table, right? So it was just quickly, can I create a cluster? Can I submit a job to it? And then see the output of the logs, right? So what we're going to do today is see what kind of configurations you need to have in your DAG code to map and do the exact same thing we did, but have it orchestrated by Airflow, right? And so again, we're going to do the same thing. We're going to create a cluster. We are going to submit a job to it, specifically Apache Spark, and then we're going to destroy it upon the previous task completions. If you're not familiar with Google Dataproc, it's a fully managed, highly scalable service for running Spark, Flink, Presto, etc., other open source components. It lets you take advantage of these open source tools to do batch processing, querying, which we'll be doing today, streaming, and also machine learning. Obviously, with Spark, you have Spark ML. And one thing to note is when you're spinning up your clusters, like we took a look at on Monday, if you want to see what that looks like when doing it manually, you can check out our YouTube video, youtube.com/AnantCorp. You can also find it on the Cassandra Lunch playlist. But essentially, we showed you if you wanted to deploy your Dataproc cluster with specific components like Jupyter, Zeppelin, or Presto, there's checkboxes you can select upon your configuration when you're deploying your cluster. Today, we won't be doing any of that. We'll just be saying use the default, and then which is going to be Spark, right? And then these Dataproc clusters are quick to start and shut down. We're not going to be taking a look at scaling, but you'll see in the DAG when we run it, it happens pretty fast. And then there's also built-in integration to the GCP platform as general. We're going to be using cloud storage in our demo specifically to host our Secure Connect bundle that is the authentication packet to Astra, as well as our jar code itself. And then we can also interact with the code like we'll be doing via the REST APIs, which is pretty much what the Airflow operator is. So there are some things I note in the code if you're looking at it that if you're using specific things from the REST API, how do they map to the way you have to set your dictionary key values? We'll take a look at that once we get to the demo portion. If you're not familiar with Dataproc, you can also run it on serverless, but today we'll be running it on GCE. In the future, we'll talk about how you can run it on GKE with also Airflow running on GKE. And so one of the things to note is that there's two major versions of Dataproc or image versions. So there is the Debian image, there's the Ubuntu image, and then there's also the Rocky Linux image. We talked a little bit about this more in depth on our talk last Thursday. So if you're interested in that, feel free to check it out. But the main thing you just need to boil down to is if you're using Dataproc release 2.0, that will have Spark 3.13 and Scala 2.12.14. If you're using Dataproc release 1.5, that will allow you to use Spark workloads of 2.4.8 and Scala 2.12.14. So things to keep in mind just there when you're running your DAGs and you're building your jar code, because that's something I ran into, right? So the jar code that I'm actually running is from a previous Cassandra launch or data engineers launch that I ran in the past, but that code was written for Scala 2.11 and Spark 3.0. And so when I was running into issues trying to run the code, I was like, okay, let me take a deeper look into this. And then that's how I saw the version releases. So keep that in mind when you're running it. And so the main things that we're going to cover today in how to get this connection working is there's a couple properties we need to set. And we'll show you how you can do this via the DAG code. We did this manually last Thursday. Again, you can watch that demo on our YouTube channel. So one of the properties we have to set is the Dataproc and script provider enable is false. This is for resolving some SSL handshake errors we get when we're trying to talk to Astra itself. So we have to set that at the cluster level, and we'll show you what that looks like in the DAG code. One thing is when you're submitting a job, you need to pass in your Spark Cassandra connector. And as mentioned, we're using the default image. And so we're going to be using Spark 3.13 from the Dataproc version level. So we need to have our Spark Cassandra connector, which is compatible with Spark 3.1. In this case is the Spark Cassandra connector 3.1. And then, as I mentioned before, when it comes to the DAG param mappings, so we have a couple things we're going to be setting in the DAG, like the cluster config, which we then pass to the create Dataproc cluster operator. Then we also have our Spark job config. And so each of these map to the REST API. And we'll take a look at that once we get to the demo portion. But essentially, the main highlights to take away here is that you need to convert the camel casing that's in the REST API to all lowercase with underscores to add spaces. And so, for example, in the REST API, one of the keys is master config, right? So converting that to what we need in the DAG would be master underscore config, all lowercase. And then if we wanted to use GKE, which we'll talk about in the future, we can swap our cluster config key for virtual cluster config, which then allows you to talk to GKE, etc. And that's if you're creating a cluster as well. But if you're submitting a job, all you need is your Dataproc cluster name. So that specific second bullet is mainly for if you're creating a Dataproc cluster on your GKE instance. Okay. And so moving on to the demo, what we're going to do is we're going to do this on Gitpod. So you can do this entire walkthrough on your browser, even a tablet. But if you want to do this demo on your local, there are some changes that you would need to make. So some of the changes you would need to make are to move the commands that are in the Gitpod YAML, which is just the Airflow install, and then install the Google Provider package, and move those into the setup script. And then you can just run the setup script, which handles creating a user, Airflow DB init, etc., and starting the web server and scheduler. And so what's going to happen here is once we have that running, we are going to set up our GCP connection. We do this using a service account key file JSON. If you're not familiar with how to do that or how to generate it or how to get it, there is documentation linked in the README. And then we'll also input our variables. We have a variables JSON file that a part of the setup script we import. And so right now they're just empty, so you can fill them out in the Airflow UI yourself. And then we're going to trigger our DAG, right? So our DAG is going to spin up a Dataproc cluster on GCE, as mentioned. We're going to submit a Dataproc Spark job to read from DataStax Astra. So we're going to pass in a couple variables, or our Astra token, client ID, client secret, the path to our bundle, our database name, our database key space, and our database key space table. And then once that's completed and we see the job log, it'll delete the cluster, but it'll start deleting the cluster right away once the submit job task completes, because that's the dependencies we have. So the first dependency is create the cluster, second task is submit the job, and then the last task is destroy the cluster. And with that, we'll go ahead and move over to our demo. So I'm going to go ahead and open this in Gitpod. I'm just going to move these up just so I can copy and paste right from the README. So the first thing we need to do is put our jar file and our zip file into a bucket. So I already have a bucket here, which has my zip file for Astra, and it already has my jar. So looking at the jar here, actually, let me bring this back down so we can talk through the code a little bit. So what's going to be happening is this compiled Spark jar is, if you open up the Spark Cassandra Scala file, this is essentially what we're doing here. We're just saying, take our arguments that we pass in from the DAG, set them as these variables, and then run a Spark SQL select all from or my catalog maps to the database, key space name, table name, and just show. And that will show the top 20 records, right? So if you wanted to make modifications to this, you can make modifications, build the jar yourself. But essentially, if you're making updates to the jar, as mentioned, you'll need to update the Scala version. And you also need to update the connectors and Spark versions that are in the build.sbt. But yeah, this is all that the jar is doing. It's just going to run a select all from database key space table. So let me move this back. Or actually, while this is happening, I am going to, let me just duplicate this real quick, move this up. And feel free to drop questions or comments in the YouTube chat. I'll be monitoring it as we go along. So coming back here, we see our Airflows already come up. So if we go into our Gitpod YAML, so as mentioned, we're going to install Airflow. And then the only reason we're installing this protobuf thing, it's something I've ran into only really on Gitpod. So if you're doing this on your local, you may or may not need to do this. But if you get errors related to, I think it's like PYB2, and it actually tells you to download protobuf to this specific version. So if that's something you run into while doing this, you can just install it and it should fix it. But again, we're just going to install Airflow. We're auto-installing the Google operator this way. And then in setup sh, we're just going to create our DAGs directory. You're going to move our POC pi, which is our DAG file. And we're going to create a user, we're going to import our variables, and we're going to start our web server and scheduler, right? And so in our variables, we have our project ID, We have our cluster name, which is going to be our Dataproc cluster, our region, our jar URI, which is going to be our gsutil URI to point to our jar. We have our Astra bundle path, which is the gsutil URI to the Astra bundle. Astra username maps to the Astra token client ID. Astra secret maps to the Astra client secret. Astra DB name is our database name, key space name, table name, right? So if you're not familiar with any of these, if you get confused about the mappings, you can always look at the Python code, and I have some comments here for you. Okay, so what we're going to do is we are going to go ahead and open up our Airflow. Let's just make this public, and we're just going to sign in with admin. And we see right here, example Airflow Google Dataproc Astra, right? So this is the DAG we're going to be running. So looking at the actual code itself, we're going to import our variables, right? And the main things here are we have the Dataproc create cluster operator, our Dataproc submit job operator, and our Dataproc delete cluster operator. So first what we're going to do is we're going to take a look at the definitions of these operators first, and then we'll take a look at how we actually did the mappings, right? So the first thing we do here is our Dataproc create cluster operator, right? So the only things we really need to pass in are our project ID, our cluster config, so that's the important thing, region, and again, region is also important because you need to submit your job to the same region that your cluster is in. We talked about this on Thursday, more at length. Our cluster name, so this is the cluster name we're going to arbitrarily give it, so it'll create the cluster with this cluster name. And then labels is if you want to have labels, this is how you can do it. So if you want to label your jobs, if you want to label your cluster, you can pass it in this way. And so this is just a dictionary, and we'll take a look at that in a second. But as mentioned, if you want to create a cluster on GKE instead of GCE, which is what we're doing, you'll need to use virtual cluster config instead of cluster config, and you can find documentation about it here linked. So coming up to cluster config, so if you remember on Thursday, if you watch at a later time, some of these things were already given to us by default when you're doing it via the UI. So these map essentially to the master node configuration and then the worker node configurations. And by default, it has to have 2 worker configs if you're doing it this way. If you tried to reduce this to 1, it'll throw an error, which is something I've run into. So something just to keep in mind is you might run into an error if you try to decrease the number of worker instances. One of the things that here is we set via the properties when we're creating the cluster manually is we set the software config out of the properties, and then we added the Dataproc conscripted provider enable as false. But again, we can set it here like this, right? So if we want to just quickly, as mentioned, open up the quick REST API. So you see here, we see master config, worker config, etc. And so you see in the DAG, we have it as master_config, but it still maps the same way it does in the REST API, but you just have to keep in mind that when you're doing it via the DAG, you have to remove the camel casing and then add underscores. All right, and then labels, we have labels here. So the next thing here is the Spark submit, right? So task ID is self-explanatory, but here is we have job and we say Spark job, right? So this is the configuration similar to when we said cluster config equals cluster config. So this is a dictionary we have defined as the job, and then we pass in the region, we pass in the project ID, right? So coming to the Spark job configuration, there's a couple things we need to add. Here is the reference, which is essentially which project we're using it on, the placement, which cluster we're sending this job to. And then here is where you have to keep in mind that Dataproc can run multiple types of Spark jobs, right? So it can run a Hadoop job, it can run a Spark R job, it can run a PySpark job. So we need to specifically say we're running a Spark job, right, as our top level key value, right? And so then within that Spark job definition, we can say here is our jar file. And so jar URI, as mentioned, it's going to be our gsutil URI. We have our main class, which is just the class as mentioned in the Scala file. So if you look here, we package it as Spark Cassandra, and our class is POC, right? So coming back here, we then pass in our arguments, which is mentioned if you look back at the Scala file, our database name. So the order is here is important because that's the way we're picking it up in the Scala file itself. But again, that's handled for you in the DAG code. So all you need to do is just really fill in your variables once your Airflow UI is up. And then we have labels. So if you want to add labels to your specific Spark job, you can as well. And our labels, again, is just a dictionary with our key and our value. And then the last thing we have here, you don't need any specific configuration for the delete cluster operator. You just need the project ID, the cluster name that you're trying to delete, and then the region that it's happening in. So as mentioned before, here's our dependency list. So we start with create a cluster. Once that completes, it'll submit the Spark job. And then once that completes, it'll destroy the cluster, right? So now going to actually how to get this connected, first thing we need to do is set up our GCP connection. And so if we go into the admin connection section and we just search for Google default and we edit the record. So there's a couple ways you can do this. The one way that I have defined in the README is just to take your key file JSON, which is essentially a JSON file which points to your service account, and then add that to the repo, right? So you could do this via Google Secrets, but then you would need to manage Google Secrets Manager via the Airflow configuration. But this is just the easiest way to get it done. You could also just copy and paste the contents of this file and then paste that into the key file JSON input. But one thing to keep in mind is that they mention in the Airflow documentation only to use one of the options, right? So if you're going to be using key file path, only use key file path. If you're going to be using key file JSON, only use key file JSON. Same thing applies for these other ones here. So if it's in the key file secret name, only use that one. All right, so what we're going to do here is we are going to copy the path and we are going to paste that into our key file path. And then we are going to quickly test it. Connection successfully tested. So we're going to go ahead and hit save. And so now the next thing we need to do is set up our variables, right? So these variables get passed into the DAG as you saw before. So the first thing we need to do is our Astra bundle path. So if we go back to our bucket, I am going to copy the GS util URI and then paste that in. And then the next one is our Astra DB name. So mine is called Databricks. And then the next one is key space name, which is test. And so this way is, this POC is meant to be in a way where you can just validate your data, right? So I made it configurable in a way where you can use your own database key space table and just make sure the connection works properly. If you want to extend this and then add actual ETL, go for it. Again, as mentioned, if you look at the Scala file, you can see where the base repo for this is and some modifications that you need to do. But yeah, so Chipotle stores is my table name. And again, this is dummy data imported via the Astra UI. So if you don't have any data and you want to, you can use their data importer and it'll do it for you. Just need to select what your clustering columns will be and your primary key will be. And then jar URI is going to be our jar GS util URI. We're just going to paste that in. And then our project ID. So if we go into here, let's just copy my project ID. And again, if you've never used Google Cloud, I'm using a free tier. They give me $400 worth of credits. I think generally it's $300 or $400 worth of credits. So feel free to check it out. You should be able to do it for free. So project ID, paste it in. And then our region is going to be US East 1. And then our cluster name, we can just name it something like demo. Again, this is an arbitrary value, so it'll create this cluster called demo, then it will run the job to the cluster to demo, and then it'll destroy the cluster called demo, right? So the last remaining two variables we have are the Astra username and then the Astra secret. So if you don't know how to create those, what I'm going to do here is just show you how to quickly do it. Is we want to go into our billing settings. Again, Astra's free to use. They give you credits to use. No credit card required. So if we go into token management and we just do, I'm just going to do admin for ease of use. And so what I'm going to do is just copy this value. Again, this token will get destroyed right after this is done. That's going to be our Astra username, client ID, and then our client secret is going to be our Astra password. So we're just going to copy this and then go back into Astra username, paste, and then, oh, let me reshare, apologies. And then we are going to paste in our Astra secret and save. All right. So those are all our variables. We're all set. We're all ready. So let's go now to our DAGs. So we're going to go ahead and turn on our DAG. And if we go into it, and we are going to go ahead and hit run. So we'll see it get started. So we can see it in the graph view or the grid view. We can leave it as is, but we see that this is now running. So if we click on it, we look at the logs, we can see that it started. And then if we now go to our Dataproc and just do a quick refresh on this, we now see our demo cluster getting provisioned. Great, yay. And so some of the things you can also set when you're doing your cluster config is where your staging bucket is. But again, it'll create one for you if you don't have anything there already. And again, it's taken our 2 worker nodes, and then it's taken our region that we passed into it. And then just to confirm that it's properly picked up our property that we defined, right? Because we defined, let's go back to our code. If we go back to our properties, we've added Dataproc and script provider enable is false. So if we now go back here and we take a look at our show properties, we should see Dataproc and script enable provider as false, right? So this will only take about a minute or 2 to come up. It's pretty fast. Feel free to drop questions in the chat. I got it up. So now once this happens, we can go ahead and go to our job section, and we'll see our job get submitted. And then let's go to our dashboard here. So what we're going to do here is just take a look at the data that we're going to be querying from Astra. So if we go into my Databricks database, go to SQL console, we're just going to do a select all from test.chipotle stores, right? So this is ideally the data we should be getting back once our job submits, right? And so if we go back to our Airflow UI, let's take a look here. So we see it's still running. So if we go back to our jobs or clusters, we see it's now running. So we'll just give it a couple seconds. Let's see if the job has started to pick up. All right, we see our job task has now started. And so now if we go into our jobs and we do a quick refresh here, we should see now our job show up, right? Loading jobs. All right, so we see our job starting up. Now if we click on the job, we can look at the configuration, see if it mapped properly, right? So we see our region, correct. Our cluster, correct. Spark job, correct. Our main class, our jar file. Properties we pass in as mentioned. We pass in the Spark Cassandra connector, and then we pass in our arguments, right? So it's properly picked up the variables we set, it's pulled it in and submitted the job with those arguments. So if we just give this a couple seconds, we see our data come through. So we see our state, location, address, and these are Chipotle stores, right? And so now that this is completed, we now see our cluster getting deleted, right? So if we go back to Airflow, just give this a quick refresh. So the Spark submit is completed, and now it's starting the delete cluster. And so this delete cluster doesn't take very long at all. So if we now go back to our cluster is now gone. So with this DAG, we've orchestrated creating a cluster on GCE Dataproc, submitting a Spark job to it, and then destroying it once it's done, right? So we're creating it, submitting our job, and once we're done with it, we don't need it anymore, just go ahead and delete it. And so, yeah, that wraps up the main demo portion of today's talk. Some things to look out for in the future. We're going to be taking a look at running this system essentially on GKE. So potentially using Terraform to spin up our GKE. And then on GKE, we can also use Airflow and Helm charts to deploy Airflow. And then we can use git sync to then talk to our repo, get our DAGs, and then we can also import variables via the Helm Airflow values file. So there's a work in progress. We're working on it right now, but we have made good progress, and we should be able to show it off sooner than later. So keep an eye out for that talk if you're interested on running Airflow on GKE, Dataproc on GKE, and then having that talk to, for example, still use the same jar and have it talk to Astra. But yeah, that wraps up today's talk. Feel free to drop any questions in the chat. We'll give everyone a minute or two to ask any questions. All right, doesn't look like there's any questions. Thank you everyone for joining us here at Data Engineers Lunch. I hope you were able to learn something. Take it away, play with it. The repo is linked in the YouTube description as well as the YouTube chat, so you can get it there. And if anyone has any further questions, we'll go ahead and wrap it up for today. Thank you everyone for joining us here. And don't forget, we've also released our 9th free Apache Cassandra runbook. The link is also in the YouTube live chat, so get it while you can. It'll only be available for a couple weeks. And with that, we'll go ahead and wrap up today's talk. Thank you everyone for joining us.